found the acceleration, the friction, the coefficient of friction, the velocity at the lower part of the incline. So this is using the Newton laws, the typical question I would ask. Now, I can use also to find the velocity, energy, and then once I have the velocity, I can find the acceleration using the big three. So, energy. The energy approach. As I said, the force of friction is static. My bad. It's static. So if it's static, what did I say that is the work done by the friction? And if the work done by the friction is zero, there is no non-conservative force. I can use the third theorem, which said that energy mechanical conserve. And now I go and I said, okay, since the energy conserved, the energy have to be the same at the top than at the bottom. At the top, what type of energy? Potential. What is the formula? mgy or mgh. So since at the beginning we have only potential energy, gravitational, and at the end, when the object is going to the bottom of the incline, what type of energy? We have only kinetic energy. You can see the potential energy get reduced, up to here, assuming that this is at the lower part of the incline, will be only kinetic. But what type of kinetic energy? Is the center of mass moving? If the center of mass is moving, what type of energy will be? Rotational or translational? Translational. When the object is at the bottom, other particles are moving as well? They are moving. So also we'll have what type of energy? This is the energy. So you told me that the potential energy gravitational is mgh. What is the definition of kinetic energy translational of the center of mass? The whole mass is at the center. What is the formula? 1/2 mv squared. B of the center of mass. And what will be, by analogy, the kinetic energy of rotational motion? 1/2 I omega squared. mgh equal 1/2 n BCM plus 1/2 I. What is moving here? What object is moving here? What type of object? The disk. And what is the moment of inertia of the disk? So if I give a sphere, the only thing you need to change here is that will be a sphere. You just have to know the moment of inertia of the sphere. I will give. So mr squared will be 1/2, because it's a solid disk, will be 1/2 mr squared. Time what? Omega squared. But how omega and v are related? How v and omega are related? There are three equations that relate the linear to the rotational. Omega over v is omega r. Omega is v over r. Is that correct? So I can replace this by the v of the center of mass divided by the radius. And I square. What happened to this and this? And now I can factor out BCM. I can factor out 1/2. So I will have 1/2 m BCM squared, and in this case I will have 1 plus 1/2. M. So I will have GH equal. How much is this? 2 plus 1, 3, 3 over 2. So it will be 3 over 4. Is that correct? 2 times 1, 2 plus 1, 3, 3 over 2. And 2, 4, 3 over 4, BCM squared. So what will be BCM for the disk? 4 over 3 GH, the square root. This is finding BCM from energy perspective. Can you see here? The same, right? So this was found using the Newton laws. That was found using energy perspective. Same answer. You can find the velocity with either perspective, whichever for you is easier. Now, I can ask from here, find the acceleration. What do you use in order to find the acceleration? If you have already the velocity final and velocity initial, and you have the height, what do you use to find, or you have delta x and sine theta, what do you use to find the acceleration? What is the easier way to find the acceleration? Before we have the acceleration and what we use to find the velocity? Before? The kinematics equation. Now you have velocity initial, velocity final, and the displacement and the angle. You go back to the big three and find the acceleration. And then, in order to find the friction and mu, there is no other choice than to apply the Newton laws. You understand what I mean? I leave for you how to find the acceleration using, so once you have the velocity, how do you find the acceleration? I leave for you. It's a homework. Which is just to apply, to come here with this BCM and come back to here. This is 0. Find the acceleration. It's not 2h delta x. You will find the acceleration. So you will have this, and you just need to come here. Remember that delta x is h over sine theta. H over sine theta. H is delta x sine theta, but delta x is h over sine theta. So that will be from where is coming the sine theta. So I leave that for homework. For you to find the acceleration. And then you just have to apply the Newton laws. This, question number 2. Everything in the board. I can ask anything. I can ask for the acceleration, for mu, for velocity. So you don't know what I will ask. But will be a rolling motion. An object I will throw on the inclined plane, generally speaking, and you will find anything on the inclined plane. Question number 2, free response. The final topic. So if you go to here, to the study guide, multiple choice, the first study guide, you can see here that I divide the study guide in chapter 10 and chapter 11. In chapter 10, mainly was in the first page, kinematics of rotational motion, application of the big three, and the derivative and all this with the new terminology.